Hello and welcome to the Math by Matthew free homework help class this Monday, August 14th at 7 p.m. We are coming to you live from Tucson, Arizona, and today we will be answering as many of your questions as possible. Thanks for taking the time to join us today and get your question answered. Paul will be communicating with you directly through the Zoom chat to help get your questions answered. Let's start by taking a look at the question of the day. This question offers daily practice and is a tune-up for college entrance exams like the SAT and ACT. This question and full solution can be found on the Math by Matthew website at www.mathbymatthew.com. A new question is posted every day with the full Math by Matthew method explaining how to solve it. Let's take a look at today's question. Today's question says, if h of x equals f of x plus 6, which of the following is an x-intercept of h of x? You'll notice that we're given a function for f of x, but it's not asking about f of x, it's asking about h of x. We see that h of x is f of x plus 6, and since we're given f of x, we can substitute that in. So h of x is really minus 8, absolute value 3x minus 3 plus 2 plus 6. So we substituted in f of x here. Now it's asking for the x-intercept. For those that are familiar with absolute value functions, there's three possibilities when it comes to absolute value functions in terms of their x-intercepts. The first is that they might have two x-intercepts. They might have one because the function bounces. And it's also possible that they might have none or 0 x-intercepts. Since the answer space, the multiple choice answers have numerical values, we are likely looking at case 1 or case 2. So to find the x-intercept, we're going to set h of x equal to 0. So we're going to put 0 in to the left-hand side here. And 2 plus 6 is 8. We want to isolate the absolute value term here, the absolute value of 3x minus 3. That means we want to get everything else on the other side of the equation. To do that, we'll subtract 8 from both sides. And then we're next going to divide by negative 8. So we're going to divide both sides by negative 8. So we get 1 equals absolute value 3x minus 3. It's often the case that you end up switching the sides here. So we'll turn this into 3x minus 3 absolute value equals 1. And then we're going to use a property of absolute value. So the property is I've got something inside here. I'll call it f of x for lack of a better. And this equals a number. So we set this thing inside the absolute value f of x equal to that number. And then we also set it equal to the negative of that number. Now this assumes that this number right here is actually positive. We're not going to get into any special cases today, but that means we're going to set 3x minus 3 equal to 1, comma, 3x minus 3 equal to negative 1. I'm going to add 3 to both sides, plus 3, so I get 3x equals 4. Divide both sides by 3, so x equals 4/3. Do the same thing over here. I'm going to add 3, so I get 3x equals 2. Divide by 3, x equals 2/3. So we have two x-intercepts, one at 4/3 and one at 2/3. Let's go back and take a look at the answer and see if we can find the correct value. Looks like just 4/3 is there. That's how you answer the question of the day. Right now, I'm going to show everyone how to actually find the question of the day. So you want to open up your browser and go to mathbymatthew.com from a phone or your computer, and you'll see on the home page there's a tab for question of the day. The question of the day appears in this space below. The question itself offers daily practice and is a great tune-up for college entrance exams like the SAT and ACT. If you need a little more practice, consider purchasing our Question of the Day practice book under Practice Materials. All right, we're going to take a look at another question. We'll get set up here. And let's see who we're going to be helping next. All right, looks like we got Chris R. from Tucson. He's asking about factoring. So he wants to know how to factor 3x squared minus 3x minus 90. Let's see if we can get Chris R. See if we can get Chris R. here. Hey Chris, how you doing today? All right, so are you in high school?
Freshman. Yes.
You're a freshman in high school, that's awesome. And looks like you're taking maybe an Algebra 1 class?
Yep.
That's great. So you're already up to factoring. That's pretty advanced for someone taking Algebra 1. Usually they don't cover that until a little bit later in the year. I'm going to go ahead and solve this problem, and I'll check back with you, okay?
All right.
All right. The first thing you do when you factor a question like this is you have to remember there's a ton of different types of factoring. The most common one is GCF, or the greatest common factor. So we notice that there's a 3 that goes into each of the numbers, or each of the terms here. So if I factor 3 out, I get 3 parentheses x squared minus 1x minus 30. And if you're not sure that this is correct, you can always distribute in the 3 to see that you get back to the original one. So we factor out the 3. The next thing we do is we look at the numbers inside parentheses here, and this is really the thing that we're factoring. This is considered a type A equals 1 because there's a 1 in front of the x squared. It's also such that, and this is one of the finer details, it's the case where you have both negatives inside here. There's a negative 1x and a negative 30. You're going to look at the factors of negative 30. So the factors of negative 30, there's a lot of them. You can write them over here like negative 1 and 30, 1 and negative 30, negative 2 and 15, 2 and negative 15, and so on. And what we're looking for is they have to be 1 apart, or actually negative 1 apart, this middle term here, when we find the correct one. So you can make this list here. I'm going to keep going here. It might be negative 3 and 10, 3 and negative 10, 5 and negative 6, negative 5 and 6. And we realize that, hey, these two, they add up to 5 plus negative 6, they add up to negative 1. So we write our factors of x plus 5, x minus 6, and this is now considered completely factored. There's a ton of different types of factoring. So the fact is that this is just one of many types that you could see here, and it's one subcase of many other types of factoring. So Chris, while you might be able to do this one, just keep in mind that there's a lot of other factoring that you'll be expected to learn. Hey Chris, you still there with us? Chris, you still with us? All right, any follow-up questions to that?
No.
All right, well, let Paul know if you've got another question. I'm gonna see who's next on our list here. So just a reminder for some other products and services that we have available to you. We previously talked about the practice materials. If you want to schedule a lesson with Matthew, that would be me, at any time, go to the Meet with Matthew tab, and we have several different options. We've got private tutoring. That's great for someone who wants a one-on-one personal experience. We probably won't be able to answer all your questions today, but we'd be glad to answer them one-on-one with you. We also have a great SAT, ACT practice individual one-on-one sessions with some study materials that we provide. We're also offering a lot of group classes right now where we're covering different content areas for standardized testing as well as some test taking strategies. And for most of you, you're here tonight because you clicked on the virtual homework help or you got the link through your teacher. We'd be glad to continue to help you and just let us know how we can serve you better. We're going to jump back to a new question. Looks like we've got a question from Billy in Phoenix. See if Billy is there, but we're gonna paste his question in. All right, so Billy has a statistics question. Hey, so Billy's asking us about a number that is chosen from random from the set of two-digit numbers from 10 to 99 inclusive. What is the probability the number contains at least one digit 2? All right, so there's a lot going on here. They're asking the probability that the number has at least one digit that is 2. So an example of this would be, for example, 12. 12 has 1, 2 in it, okay? Another number that would be correct is 20. But we don't want to have to count all these, so we're hoping to find a better way. The probability is always expressed as the ones that we care about over the total possible or the space of the answers. So 10 to 99, if you're not sure how to count that, we know that from, for example, 1 to 100 is 100 numbers. Well, how do we get that? Well, we take the large and we subtract the small and we add 1 to it. So here we're going to subtract 99 minus 10, and then we're going to add 1 to it. So that means that there are 90 total possible. So the probability of at least one digit that's a 2, we know is going to be over 90. So now we got to find them all. We will be listing them, but we don't want to necessarily list them all. So we know that there is 12, 22, 32, 42, and so on, all the way up to 92. So you can see it's 1, 2, 3, 4, 52, 62, 72, 82, 92. That's 9 total. So put a 9 up here. Plus, we got a bunch of numbers from 20 to 29. Now we know that there's 10 here, but we already counted one. So there's another 9 in there. So we've got 18 out of 90, and we reduce that to 1/5. All right. We're going to move on to another question. Let's see who has another question for us today. All right, looks like we're going to talk a little bit more about probability and statistics until we get another question coming through here. So one of the things that a lot of people will see in their probability in class is rolling 2 dice. And if you're not familiar with the dice, it's a cube. It's got 6 sides, 6 faces, and it's got the numbers 1 to 6 on there. So there's a lot of dice games at casinos and various other places, but in classrooms we can ask what the probability is of various events. So for example, if you roll 2 dice, there's a lot of possibilities you can get. You can get a 1 and a 1. You could get a 1 and a 2, 1 and a 3, 1 and a 4, a 1 and a 5, a 1 and a 6, okay? Or you could get a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, 2 and a 5, 2 and a 6, and so on. So we get all of these up to a 6 and a 6 as a possibility. So we might be interested in knowing a lot of things about rolling 2 dice. We might be asked, hey, what's the probability that if you roll 2 dice, the sum is 5? Okay, well, how do we get a 5? Well, there is no 0, so it has to be a 1 and something else, or 2 and something else, or 3 and something else, and so on. So we can look for these possibilities. We know that there is a sum of 5 is 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1. These are related to the dice rolls, dice throws, 1 and a 4, a 2 and a 3, a 3 and a 2, a 4 and a 1. And we can see that there's 4 possibilities. Now, what's the total possible outcomes when you roll 2 dice? Okay, if you were to make this table, you could just count them up. You may not want to do that. That takes a long time. What if I had you roll 3 dice? That would take a really long time. So there's another type of problem that allows you to figure out the sample space, because we're really looking for down here is the total. How many possible outcomes are there when you throw 2 dice? Well, I call them buckets or positions. So the first dice throw has 6 possibilities. And when you throw a second dice, it also has 6 possibilities. These are the buckets, by the way, or the possible outcomes. And you end up multiplying them to get 36. The sum of 5 is there's 4 possibilities of those out of 36 total. And if we reduce them, this fraction, we get 1 out of 9. So there's a ton of other questions, I mean, almost an infinite number of questions that can be asked based on dice throwing, card games, lots of other possibilities. All right, let's just go through and take a look at just a reminder about how to access some of the services on the website. Just a reminder for anyone joining us or taking looks at this now, the homepage is at mathbymatthew.com, accessible from your phone or any internet capable device. We've really tried hard to make math easy. We have a question of the day that we provide. This is great for anybody who's thinking about taking the SAT or ACT. It comes with a full solution, and we really recommend that people practice this every day to get a little bit better. The other services available is tutoring. We can definitely meet your needs with private tutoring. Just click on the link here. It'll give you a couple options and you can schedule with us. We also have group classes upcoming in October. We want to help people get their best score ever on the SAT or ACT. And we also are offering what we're doing right now, which is the virtual homework help. This is where you get your questions answered. It looks like we've got a couple of people that just joined the room, so it might be a good opportunity to get some new questions answered. For those entering the room, Paul's going to work with you directly. He's the one that's going to help you get your question answered, get it queued up for me to answer. So please work with him. He might ask you a couple of questions. Usually we just want to know what class you're taking, whether you're a high school or college student. Really, we just want to know how to best serve you. So in the meantime, we're going to check out just some more questions that might be good to answer, or some skills. We talked a little bit earlier about absolute value functions. So we'll just make up another one here. Let's say that I give you 2x minus 3 plus 7 equals negative 3. It might just ask you to solve this. It could just be as simple as that. Hey, solve this absolute value. We're going to subtract 7 from both sides. Absolute value 2x minus 3 equals negative 10. I'm sorry, I made a mistake here. Let me change this number here. Let me make this negative 7. We'll add 7 to both sides and we'll get 4 here. That makes this problem more reasonable. So the property I mentioned earlier that's really important here is that we set the absolute value we really have two possibilities. We have the setting it equal to the number itself, and then setting it equal to the negative of that number. So that's this property. I wrote it this way: f of x, it's usually written like this in textbooks, equals c, and you get two possibilities: f of x equals c, f of x equals negative c. There is some constraints here though. C has to be greater than 0. C could be 0. When it is, you only have to do one of these cases. If C is less than 0, this has no solution. We showed that graph earlier. It's a V where it just never hits the x-axis, could look up or down like that. Luckily for us here, we've got some that do have a solution, so we'll continue solving them here. So we're going to add 3 to both sides, add 3 to both sides. 2x equals 7, 2x equals negative 1. So we have x equals 7 halves, x equals negative 1 half. All right, looks like we've got a question from a participant. Just a reminder that if you want to participate, Paul's going to interact with you. He's going to ask you some questions. Looks like we've got to talk about some properties. We got Chris R. from Tucson. Hey, Chris, looks like you got another question today. Hey, Chris, try to speak up as much as you can so I can hear you.
Sure.
Hey, Chris. Hey, what looks like you've got some questions on some properties here. Do you need some examples of these, or are you trying to use them in a homework question? What do you got going on?
Just a homework question.
All right. Do you have that? I'm not seeing that on my screen yet. For the homework question, is that something you can tell me verbally?
Sure.
Okay. Whenever you're ready, be happy to hear that.
All right, the first one is 7 open parentheses 16 divided by 4 square close
Something.
parentheses.
Okay. Do I have it correct on my screen?
Yes.
All right. And what is it asking you to do in this question? What is the?
Um, asked me to find what the work is that's being used in this problem and just how do I do it?
How to simplify this? Is that the instructions?
Yes.
Okay. All right, well, this is really an order of operations question, and the order of operations, they're presented in the classroom as PEMDAS, P-E-M-D-A-S. I had a great 8th grade teacher, and he actually showed it to us differently, and I actually prefer it because it's got a lot more versatility than PEMDAS. This gives us the flow. When you simplify, you go in this order down this way. You're going to be solving equations later on, and when you solve, you go up this way. The first or highest precedent here is parentheses. So you look inside parentheses, and what I see is I see division and I see an exponent. So I got to choose between division and exponents. Regardless of whether you use PEMDAS or this other thing up here that I wrote, you're going to do exponents first. So we're going to do 4 squared. 4 squared equals 16. So we're going to evaluate this thing, meaning we're going to replace 4 squared with 16. So we continue to look inside parentheses, and we only see division now. So we chose exponents. Now we're going to do division. We know that 16 divided by 16 equals 1. So we evaluate it, meaning we replace that inside there with 1. This next step, there's implied multiplication here. And that's the only operation I see. 7 times 1 equals 1. So this simplifies to just 1. Chris, I'm going to unmute you again.
All right.
Did that answer your question?
Yes.
All right. Do you have any other follow-up questions for this?
No, that's it.
All right. Well, I really appreciate you taking the time to ask your question today. Well, that's it for this meeting, everyone, or this class. We really appreciate you taking the time to come out today and ask your questions, and we look forward to helping you again. Our next virtual homework help is going to be this Wednesday at 4 p.m. Please go to the website and connect with us there. You can get contact information for this class, and we will post the video, the screen recording for today, onto our YouTube channel. And we look forward to helping you guys out in the future. So thanks so much, and we'll see you next time.